Hello! In this video, we'll be looking at the combination of Cloud Armor, which is a web application firewall or WAF system, with Kubernetes and specifically Google's Kubernetes Engine, also known as GKE. This is a really powerful combination that allows you to create advanced web applications on Kubernetes clusters and then protect them. This includes features like rate limiting and other security capabilities using the Cloud Armor service. We're starting with an Autopilot cluster, which uses a managed approach for things like node pool design. It's a bit opinionated, meaning Google makes some decisions for you, but it works perfectly fine for our demonstration today. Once our cluster is created, we'll connect to it using kubectl, and we're also going to create some YAML files for our Kubernetes resources. You can use whatever IDE, editor, or terminal you prefer, but for simplicity, we're going to use the Cloud Shell IDE, which is built directly into Google Cloud and is completely free. If you're using Google Cloud, this will be an easy option for you to follow along with. First, let's open a terminal and create a small directory for our project. We'll open that directory and get started. Don't worry, we'll share all this code in the video description so you can follow along. We really just need a couple of files to get started. We'll create a deployment file first, and then we'll create a service file. These will set up a simple application using Kubernetes resource files. Since these configuration files aren't really the main focus of our video, I'm just going to paste them in to save time. In our deployment file, notice that we're using the Nginx latest image, running 2 replicas, and exposing HTTP port 80. In our service file, we're using a load balancer type service and pointing it at our Nginx application, also on port 80. Let's deploy these resources first before we actually implement Cloud Armor. The Cloud Shell IDE comes with gcloud commands already installed, which makes it easy to authenticate with our cluster. Right now, nothing's running on the cluster yet, but it's good to use kubectl get commands just to make sure we have proper authentication and network connectivity, which we do. Now we'll apply the current directory, which will create both the service and our deployment. Note that it also patches our deployment to give it minimum CPU and memory requirements, which helps create a more stable setup. If you prefer, you can also use the GUI in the GKE console to check out these resources. For example, here's our Nginx deployment. When we check our pods with kubectl get pods, we can see they're pending. This is just because Google Cloud is provisioning nodes that can handle these pods. Within a minute or two, we should see our Nginx deployment running. Let's make sure we can access it using the external IP, which we should get shortly since we used a load balancer service type for our Nginx service. Great, here's our external IP address. When we access it over HTTP, we can see the Welcome to Nginx homepage. Perfect. Now comes the exciting part, which is adding a backend configuration to enable Cloud Armor. We can bundle this with our service resource since they're closely related. We're going to use a Google Cloud-specific API version with the kind set to BackendConfig. Just like normal Kubernetes resources, this takes a name and will also have a spec section where we can specify a security policy. This is how we connect Cloud Armor to our application. Let's name this Nginx to keep things simple. It's important to note that we need to create the Cloud Armor security policy before we actually reference it in our backend config. Once we have this resource created, we also need to connect it to our service. We do this through an annotation, specifically cloud.google.com/backendconfig, which ties everything together. So the concept is fairly straightforward. We have our networking resources, which include our service and deployment, plus the backend config, and together these will give us web application firewall protection. Now we need to create the Cloud Armor policy itself. We can do this either in the console or through something like Terraform. For this video, it's easier to show creating the policy in the Google console, so let's do that. Very importantly, you need to make sure that the name you give your policy matches exactly what you reference in your backend config. As a simple example, we'll create a policy with global scope, set it as a backend security policy, and have the default rule action set to allow. Then we can add some interesting rules, including advanced mode rules. With advanced mode, we can use the Common Expression Language, or CEL, and can even specify ModSecurity core rule set rules to protect our application. There are also advanced features like rule tuning and CAPTCHA integration that we can add. There's really a lot of cool functionality available here. We'll need to set a priority for our rule, and we'll say that once we match a certain security condition, we'll block that request with the 403 forbidden response. A fun example, even though we could filter on things like IP ranges and various Layer 7 attributes like headers, is to use the pre-configured WAF rules. For example, this SQL injection rule can protect our application from SQL injection attacks. The sensitivity setting is really important and is something that's often missed when people first use Cloud Armor. If you use these CRS rules without specifying any sensitivity, it'll default to maximum sensitivity, which means it will flag all sorts of things that could possibly violate these rules. At low sensitivity, it will only catch things that are very obviously SQL injection attacks. As you increase the sensitivity, you'll see it start blocking more things, including certain characters, and applying more loose rules about what traffic to block. Let me demonstrate this. Let's start with the pretty high sensitivity setting. We don't want to apply the policy to any targets directly here because we're going to do that through our Kubernetes configuration instead. We'll also leave things like DDoS protection and other features disabled for now. I should mention that when we create policies, and especially when we attach and update them, it can take a little while for these changes to apply, so just be patient. Let's reapply all the files in our repository. This will create our backend config, and hopefully if we refresh the console, we should see a target added to our policy. We're not seeing the target appear yet. Let's do a sanity check on our configuration. Our service does have the annotation we expect. Let's also check the load balancer itself. I see the issue. This is a Layer 4 load balancer, which means it's only dealing with TCP traffic and can't handle the Layer 7 features we're trying to use with our backend config. We need to add one more layer to our setup, which is an Ingress resource. In the Ingress, we can specify classes within annotations, and in the spec section, we really don't need much. We just want to specify a default backend that points to our Nginx service on port 80. We don't need anything else for this simple example. The names will match up automatically. Since we don't need to expose the service directly anymore, let's switch it from load balancer to either node port or cluster IP. Let's apply our resources again. Still not having luck? Let's check our Ingress status. It looks like it's still being created, so that might be why we're not seeing our target yet. Let's give it another minute or two. It looks like our AI code completion tool led us astray a bit with the backend config annotation. We actually need to supply a bit more information. Specifically, we need to add a ports field in the annotation, and then specify that port 80 is where we want to use this Nginx backend config. That's looking better. Our annotation seems correct now. Let's check our Cloud Armor policies again. Bingo. We've got a target now. Remember, this is set to high sensitivity. So if I refresh the page, oh wait, we need to switch to using the Ingress IP address instead of the service IP. Let's find out what that Ingress IP is. Let's make sure everything is working properly with this Ingress by looking at the load balancer that backs it. You can see the Ingress here in the console, and it looks like our backend is healthy, which is good. We have our security policy in place, and we're using the IP ending in 253 on HTTP. After a few refreshes, we've got our Nginx page loading through the Ingress. Great. Now, what's going to make this really interesting is if we do some clever things with our requests to potentially trigger that SQL injection prevention rule. We'll want to go to the Network tab in our browser's developer tools to manipulate our requests. We can see that we get what looks like a 200 OK response from our request to the main page. Most browsers have a resend or replay feature for network requests. I'm using Firefox here, but Chrome and other browsers have similar tools. We're going to take this request, leave all the headers basically as they are, but down in the request body or parameters, we'll add some content that looks like SQL injection attempt. What I expect to happen is that when we send this modified request, we should actually get blocked with the 403 forbidden response. Still getting a normal response. Maybe it's because we're trying to do a GET request. GET requests typically don't have bodies where SQL injection would normally occur. Let's try changing this to a POST request instead. And there it is. That's the 403 forbidden response we were looking for. So now we're successfully protecting our application at the edge with that web application firewall, using mostly standard Kubernetes abstractions to configure it in a really clean and lean way. I want to emphasize how powerful this setup is. We're using familiar Kubernetes objects like services, deployments, and ingresses, with just the addition of that Google-specific BackendConfig to get enterprise-grade web application firewall protection. The Cloud Armor service is inspecting our traffic at layer 7, looking for malicious patterns, and blocking them before they ever reach our application pods. The SQL injection rule we demonstrated is just one example from a huge variety of protection rules available. Cloud Armor includes the OWASP ModSecurity core rule set, which provides protection against the OWASP top 10 security risks. This includes things like cross-site scripting or XSS attacks, remote file inclusion, protocol attacks, and many more. You can also create custom rules based on IP addresses, geographic locations, HTTP headers, cookies, and other request attributes. The sensitivity setting I mentioned earlier is really crucial for production deployments. If you set it too high, you might block legitimate traffic, which is called a false positive. If you set it too low, you might let through actual attacks, which would be a false negative. It's important to test thoroughly and potentially start with lower sensitivity and gradually increase it as you understand your application's traffic patterns better. Also remember that Cloud Armor provides more than just blocking capabilities. You can configure it to rate limit requests, which helps protect against denial of service attacks. You can add CAPTCHA challenges for suspicious traffic instead of outright blocking it. You can also use it for geographic restrictions if you need to comply with data sovereignty requirements or want to block traffic from certain regions. The integration with GKE that we've shown here makes it incredibly easy to add this protection to your Kubernetes applications. You don't need to modify your application code at all. You just add the backend config and annotations to your existing Kubernetes manifests, create the Cloud Armor policy, and you're protected. I encourage you to explore all the different types of rules and configurations available in Cloud Armor. Try different sensitivity levels, experiment with custom rules, and see how the rate-limiting features work. The documentation provides great examples of common security scenarios and how to configure Cloud Armor to handle them. We hope this video was helpful in showing you how to combine Cloud Armor with Google Kubernetes Engine to protect your web application. Thank you for watching, and please enjoy responsibly.